Do subscribe to eKida channel and press bell icon to get updates about latest engineering, HSC and IIT-JEE main and advanced videos.
Students, today we'll discuss about another physics paper, JEE Mains Physics 2014. So let us discuss all those questions one by one. Okay. Students, let us move to the next question. Question number 20. The coercivity of a small magnet where the ferromagnet gets demagnetized is this. The coercivity of a small magnet where the ferromagnet gets demagnetized is this. So the coercivity value is given, that is H value is given. What is given? This is H value. The value of H is 3 ampere per meter. The current required to be passed in a solenoid. So there is a solenoid like this. The current comes in and goes out. This is the axis of the solenoid. And the current that comes in is I. So you have to find that current I. The current required to be passed. Suppose I is the current that is passed in the solenoid of length 10 centimeter. So the total length of this solenoid L is equal to 10 centimeter, and the number of turns present here is N equals to 100. Okay, so that the magnet gets demagnetized. So that the magnet gets demagnetized when inside the solenoid. So basically the solenoid can magnetize the substance or demagnetize the substance, but here it is used to demagnetize the substance here. Okay, so that the magnet gets demagnetized when inside the solenoid. So the coercivity is this value. Okay, and you have to demagnetize that, and how much current can do that work. So in case of a solenoid, we know that in case of a solenoid, we know that if I current passes through this and the magnetic field that is produced in this direction inside the solenoid, B is given by B equals to mu naught Ni. This is the magnetic field inside the solenoid, which is supposed to be uniform, and mu naught Ni. And that is balanced by that. You have to balance that by the, you have to demagnetize this mu naught H, that to balance with this, because this has to be equal, because we have to magnetize the magnetized object has to be demagnetized, so the field should be equal. Okay, and if I want to have this value of magnetic field, then I have to apply this amount of current, this I amount of current. And for a given I, because I can increase or decrease I, if I give a certain I, so that I into multiplication of these two will be equal to this. So I don't have any choice, only I have the choice of making I different. So at a certain value of I, at a certain value of I, the magnetic field produced, the magnetic field developed in solenoid is enough to demagnetize, so that the magnet gets demagnetized. The magnet here is demagnetized. enough to demagnetize it. It means the small magnet. So now the magnetic field due to solenoid is used to demagnetize the small magnet. Your purpose is to demagnetize small magnet. So mu naught Ni produced because of this solenoid must be equal to mu naught H. This is the field, magnetic field in the magnet, small magnet magnetic field, small magnetic field. Here is the magnetic field of solenoid. If I balance this out, then from this equation I can cancel out this mu naught. Mu naught is the permeability of the free space or air, that is because this coil is kept in air, it is air, so mu naught is the permeability of air. That cancel out in both equation, and we are interested in I. Which value of I has done this? So this I becomes H by N. I becomes H by N, and in the data the H value is given. You can see there the data H value is given as this. This is your H value, 310⁻3. So it is 310⁻3 amps per meter divided by N. N is basically it is the number of turns of solenoid divided by the length of solenoid. So if I put the total number of turns is total number of turns divided by total length, that is total number of turns is in your question it is given how many turns are there. You can see it is 100 turns and total length is this, so I'll substitute that. This is 100 turns and total is 10 centimeter. This has to be expressed in meter, so therefore this is 100 divided by 10 divided by 100. So 100 comes up, so that this becomes a meter, so 10 goes, this becomes 1000. So this is N is, this is the number of turns, that is 1000 turns per meter, because 10 centimeter 100, so per meter it is 1000. Okay, so 1000 turns per meter. So now going back to the previous expression of I equals to H by N, I have H value which is how much, 310⁻3 amps per meter divided by N is coming out to be this much turns, how much, 1000 turns per meter. So per meter comes up, meter cancels, this is only A is left, so answer should be, current is there, so it should be in amperes. Now this is 10⁻3 and this is also 10⁻3, this goes, so only 3 is left, 3 amps. So the current which is responsive to demagnetize the small iron magnet inside the solenoid is 3 amps. That means if you supply 3 ampere of current to the solenoid whose turns is 1000 turns per meter, and then it can demagnetize the small magnet whose coercivity is which H value is 3 into 10⁻3 amperes per meter. Okay, thank you.